Hi, this is Shaylee, and this is my YouTube channel, AI Economics. I'm a professor of artificial intelligence, and I teach business management students AI concepts decoded for a business lens. If you're interested in this content, please do consider subscribing. Now, coming to today's video, this is part of a sequence of videos that I am making on developing generative AI applications for business managers. It's not just business managers, it's anyone who is basically not a techie or a computer science person. The rationale for this video was that I saw there were a large number of YouTube tutorials which promise the ability to create a generative AI application in 15 minutes, say. However, when I went through them, I realized there was a lot of stuff that was presumed at the back end, and which, if you do not know, you would be completely lost, or even if you manage to follow along on the code, you would not be able to generalize to your specific application. Now, this is a subsequence of videos which I am doing, which are really concerned with understanding what are word embeddings and word vectors. In the last video, I talked about what are word vectors, and I illustrated how vector algebra miraculously actually captures so much of the interrelationships between words. Now, we are continuing in this video. Also, I am going to be talking about word vectors and how they are actually estimated, and how are they estimated. Now, you might ask, since this is a bit of a deep dive topic, whether it is entirely relevant. It is definitely relevant. If you do not understand what is the basic sort of fuel that runs a large language model, you would not be able to design your chatbot or agent correctly. Secondly, even systems such as retrieval augmented generation, which is what we are trying to build up to, are very heavily dependent on the word vector, understanding what word vectors and word similarities, etc. are. So let's get to it in today's video. So why do we need to understand word vectors? Knowing that a word can be represented as meaningful numbers helps you appreciate both how large language models function and how they retrieve the correct information, and how a system such as RAG will also be able to retrieve the correct information. Word embeddings are absolutely the foundational blocks of large language models. They allow an AI to understand, for example, the similarity in meaning of different words. Think about it. Suppose you have a word such as prefer, and it is being used in a sentence like I prefer this. But you can also use I like this, or I choose this, or I select this, or I pick something, or I opt for it. These all approximately have the same shade of meaning, and hence it is important that the models are, if the model is able to distinguish between is able to distinguish these different shades of meanings. All right. Now, now let's just go to understanding how these word embeddings are actually created. Now, the first thing that this schematic shows you is, this gives you an idea of the sequencing that happens when word embeddings are created. First, we start with a huge corpus of text. Now, a model such as ChatGPT, for example, has about 480 GB of text. Now, all the words that are in this text corpus are tokenized and cleaned. What we mean by this is that each sentence is broken up into its constituent words, and each word is treated separately as a standalone word. Cleaning is just that we remove certain types of special characters and other types of garbage, which often come up, such as HTML markers, etc., especially in internet-based corpuses. We then create a vocabulary. Now, if it is a large corpus like this, it is going to be effectively, the vocabulary is going to be the English dictionary, for example. So it's a very large, huge vocabulary. Both the words that we have tokenized and the vocabulary are pushed into a deep learning model. Now, this is a very, the kind of deep learning, there is a specialized type of model called the transformer, which actually handles text modeling. Now, this is a separate, this is a fairly complex model, and I will take up a separate video on it. But as of now, it suffices to understand that it is a very large and very complex model with lots of layers. And it is specialized to analyzing text. On the basis of that, the model is then able to generate embeddings, which can then be represented as word vectors. So how do embeddings work? Let's take a very simple example, a 10-word vocabulary example. The cat, we have the following sentence: the cat sat on the mat, and we further added on words such as dog, ran, under, tree, and chair. Now, each word is going to be represented by a dense embedding of 5 dimensions. Don't worry, I'll explain this concept to you. These dimensions are loosely modeled in the kind of relationships that these words have with each other, as well as the relationship, as well as the way they are used, and therefore it enables us to understand better. Now, what does this embedding matrix look like? All right. So on the vertical column, we have all the words going down in the vocabulary, and on the horizontal column, we have the 5 different dimensions which we talked about. The numbers in the cells therefore represent what are called word embeddings. So for one word, this would be the embedding for it, which is across all the dimensions. All right, and it represents an embedding vector. Now, you might be wondering, what is a dimension? Now, we said that these basically said that the model is then, these dimensions are kind of constructs that the model constructs to understand the interrelationships between the words. For simplicity, we can assign the dimensions to the following concepts. However, we don't actually know what happens in a deep learning model, hence the black box tag to it. Now, the first dimension is animalness, which indicates what extent the word is related to being an animal. The second one is action, which reflects if the word suggests movement or an action. Location shows if a word implies a location. Then there is article function word, which basically picks out words which are articles, prepositions, or other functional words. And the last is commonality. How common is the word? Now let's look at the embedding matrix. We can see on the dimension of animalness, both cat and dog are doing quite well, and they're similar, and they have similar scores. Similarly, in the action dimension, you see sat and ran have similar scores. When it comes to location, you have quite a few. You have on, under, the mat, tree, and chair all coming in as some kind of location embeddings. All right, then article of function word is basically you have on, and you have the, and you have under. And commonality, I think it stands out that on is extremely commonly used word in the English language, and the is very commonly used. Now, and as I said, an embedding for the word cat would be across all these dimensions. So it's basically, you have to think of this as one embedding for the word cat. It is high on animalness, low on action, 0 on location, 0 on article function word, and 0.8 on commonality, and similarly for other words. So you can imagine that a deep learning model would typically learn in the range of hundreds to going to thousands of such dimensions. And this just indicates to you how subtle, what kind of subtle patterns it picks up in the usage of words. The deep learning model learns the representation of words in hundreds of dimensions, and therefore it is likely to be very subtle. The image below represents the word man and woman vectors and the king and queen, and as you can see, these seem to be somewhat similarly because they're following a similar pattern of relationship which is actually mathematically derived. Now, when we translate all these simple concepts to large language model, what happens? What is the difference? The first difference is the vocabularies are huge, upwards of 50,000 words, or typically all the words in a particular language. The second thing is embedding dimensionality, that is the number of dimensions that we are kind of learning for each word will be huge. In the beginning, the models were relatively smaller and started with dimensions like 784, etc. But now increasingly, ChatGPT, for example, is learning tens of thousands of dimensions. And each dimension represents a complex pattern of features or of word usage, essentially, learned from a massive amount of text. So I hope you managed to understand a little more on word embeddings. In this video, I have tried to explain how word embeddings are learned actually, and how they are actually derived from the data. If you like this video, please do consider giving it a thumbs up. And I mean, in the next video, I am going to be further explaining a little about how word embeddings are actually derived using the